Um, yes, hi everyone. Thanks for having me. My name is Tatia Bauer. I'm the Marsh Restoration Program Manager for Maine Coast Heritage Trust. Um, and I'm going to be doing a presentation with Matt Craig, and he'll introduce himself. But yeah, we're going to be talking about this really exciting project that's happening on the Cousins River on Freeport owned land, on eased land by Freeport Conservation Trust, MCHG land. It's this great partnership that we'll go into. And so we'll talk about kind of some of the local site context, salt marsh ecology and processes, threats to the system, a little historical detour into saute agriculture, and why that's causing marsh degradation over time, and some of the restoration strategies. And then that should say Cousins River Marsh, not Long Marsh. That's my bad. But then there might be some time for Q&A. But we'll try to keep the time going so that we can answer any of your questions. But Matt's going to kick us off with some local site context.
Thank you, Tatya. And thank you for having us here tonight. It's great to see some familiar faces. So my name is Matt Craig. I'm the Habitat Program Manager with the Casco Bay Estuary Partnership. We are based at the University of Southern Maine, but we're funded by EPA. And so we help to develop priorities for Casco Bay. And that document, if you're interested, is the Casco Bay Plan. You ask, well, who's setting those priorities? Well, our organization is governed with a management committee that includes federal agencies, state agencies, municipalities, nonprofit organizations like Friends of Casco Bay, academic, scientists, researchers, et cetera, businesses. So what I'm presenting here is just a statement of shared priorities across numerous organizations. So when we're talking about, as an organization, restoration, what are we really talking about? Well, it's generally restoration of natural processes. And over the span of several centuries, a lot of natural processes have been interrupted or broken, modified through human impacts. And there are a number of different types of impacts. So when you build a road, such as Route 1 across a tidal marsh, you inevitably alter the natural exchange of salt water and the drainage of fresh water out of a marsh. So that's an example of an impact. Obviously, filling a marsh, to build a parking lot is another example. Developing the buffer, the area right along the edge of the marsh. So there are numerous types of impacts. And restoration, therefore, is sort of the reverse, trying to undo some of those impacts. So to restore natural processes like the flooding of a marsh and the drainage of a marsh, like the peat building processes of salt marsh communities, salt marsh plant communities, and sediment deposition, fish passage, et cetera. You get the idea, right? So we're not necessarily managing for individual species. We're trying to manage the whole ecosystems so that it endures through time. That's what I think of as resilience. The Cousins River Marsh is actually a regionally significant ecosystem, and that's articulated in a number of different planning documents. Some of them are federal. On the right, there's a map of Maine priority marshes set by the Atlantic Coast Joint Venture, which is a federal-state partnership. And you can see in the middle band, it's a little small, I apologize for that, but Casco Bay and Mid-Coast Maine, there are just two marshes that were identified in this document as priorities for Casco Bay, and one of them is the Cousins. The other one, incidentally, is at the head of McCoy Bay. And part of the reason for that is because of the presence and the potential of rare birds, salt marsh sparrows, to breed on Cousins Marsh. And you probably are all familiar with McCoy Bay and Middle Bay and the conservation focus area that the state of Maine designated years ago through the Maine Natural Areas Program. But it includes the Royal River Estuary, which of course includes the Cousins Marsh. So this is certainly an important area for us all to think about and work on. That history of alteration, though, is really something that can be quite challenging to remediate. If you look back through time, you can see it in aerial imagery. This photo, I think we don't have a date for it, but you can see that Granite Street in Yarmouth goes right down to Route 1. And the confluence of the Prattsbrook with the Cousins main stem is well downstream of Green Marine. That's quite different than the layout today, right? So there have been human alterations to these natural processes that we have to incorporate into any restoration work we do. And it used to be that there were very few organizations that were even thinking about marsh restoration in Maine, let alone in Casco Bay. But today we have this terrific collaboration that is in place. And some of the folks here today, just to recognize Julia Chemnitz from the U.S. Fish and Wildlife Service Gulf of Maine Coastal Program is our coordinator. They do a fantastic job. And Maine Coast Heritage Trust is here, and Katya will speak about the work in just a moment. But it's a neat collaboration because you've probably heard John Woodruff speak from the University of Massachusetts. There's a lot of science happening out there. There are partners who have capability to do the project management, to do the monitoring, et cetera. So we all work together, and I think it's a pretty smooth running ship. If you're interested, we have a fact sheet that you can pick up. Happy to tell you more about it. But it's really a team effort. And it wouldn't be possible without the landowners who have agreed to work with us on the restoration work. And so thank you to all of you, including Freeport Conservation Trust. And I think it's important to note that there's a lot of amazing work that's happening all around Casco Bay, including in other parts of the Royal River Estuary. The Royal River dam removals are slated to begin this summer. Along with that, you're going to see returns of sea-run fish. I know Maine DMR is planning in the next week or so to seed a run of blueback herring upstream of the Elm Street Dam so that we can jumpstart that process of having sea-run fish coming back into the Royal River in large numbers. Inevitably, they're going to be using the Cousins Marsh, right? So this is a pretty significant regional effort. And with that, I just wanted to again say thank you, particularly to Carrie Kinney for your leadership on restoration. And also thank you to the Conservation Trust for your support of this work. And then hand it over to Tatya.
Awesome. Thank you, Matt. Cool. So yeah, let's hop right into this Cousins River Marsh restoration project. You can see the kind of project area map here. What I'd really like to just highlight is just how much conservation has happened on the marsh. Unlike other states, Maine ownership actually goes to the low tide line, which can make some of these projects a little difficult and tricky, but we benefit in the Cousins River system from a lot of conservation ownership of the marsh. Both, FCT, MCHT, the town of Yarmouth, they're all willing partners to, take this project on. And I just kind of want to contextualize why I'm here. So Maine Coast Heritage Trust is also a land trust. You can read our mission, but really where I sit is in our Marshes for Tomorrow initiative, which is really focused on salt marsh conservation, conservation of migration space, but also 2 full staff whose full-time job is just to do salt marsh restoration. We're really investing in this because it's a really important system to make sure is persistent through time. And then I also want to recognize our kind of expert partners in this work. They develop our restoration design plans and have been spearheading the techniques that I'll be talking about, and that is the Salt Marsh Adaptation and Resiliency Team, or the SMART teams. And they're really at the forefront of decoding the impacts of saute agriculture on salt marshes. And again, that'll be that kind of historical detour that I go into. They work up and down the Northeast region. They lead workshops and do project support. And So with let's start with ecological values and services, the kind of obligatory salt marsh slide of just why they're so important. I think they're the unsung heroes of the coast. They provide wildlife habitat. They're nurseries for marine species. So a study out of Wells found that 2/3 of commercial fisheries species spend at least some part of their life cycle in salt marshes, right? That's a really critical part of our communities. They are places where birds nest and forage. They provide flood and storm surge protection. They filter nutrients from our estuaries. They store a ton of carbon. A study out of Bates found that an acre of marsh stores 10 times the amount of carbon as an acre of Maine forest. So we want to keep that in place. And I find, salt marshes also beautiful. They create a sense of place. They're spots to recreate, go bird watching, that kind of thing. Culturally significant for many reasons, but one that's commonly known is sweetgrass. Wabanaki people have a relationship with sweetgrass, and that is found in salt marshes. And just like Matt highlighted with the Cousins River Collaborative, it's a place for partnership and science and education. And I really think it's a key component of a holistic coastal resiliency strategy. And they're complex systems, but I'm going to highlight some of the key processes that'll be relevant for kind of the how and why we do restoration. So they're intertidal systems. They're kind of in this very narrow band relative to sea level, between mean sea level and highest astronomical tide. And when the flood tide comes in, that water brings sediment that gets deposited on the marsh. It brings in nutrients, but it also, when the tide goes out, flushes kind of built up compounds in the marsh. And that sediment is kind of layered with plant roots and stems over time that builds slowly, and that's what we call accretion. And all the plant species that live on salt marshes are adapted to different flooding frequencies. So low marsh species can be flooded twice a day. Higher marsh species can only be flooded twice monthly or so. But all of the plants that occupy salt marshes need some air exposure. They need that water to go away. And so for marshes to last through time and to thrive, they need a sediment supply, they need proper hydrology, and they want the vegetation to be productive. And if you have all those pieces in place, healthy marshes can kind of keep pace with sea level rise. They can continue their relative position as sea levels rise. But there are a lot of threats to salt marshes, right? Sea level is happening very quickly. That is a threat, especially if the salt marsh is not very healthy. You have nutrient runoff from communities and roads. You have coastal squeeze, where the areas where marshes could follow sea level rise have roads or homes that prevent that migration from happening. You have a restriction from roads that kind of squeeze out that sediment and limit that input. What I'm going to focus on next is the legacy impacts of saute agriculture, which is, again, that SMART Teams piece that is this underlying history of a salt marsh that is impacting the system, which ultimately leads to broad-scale loss of vegetation and subsidence, or the slowly kind of sinking of areas of the salt marsh. So, saute agriculture, a little detour. This was a very common practice starting from first contact really through the 1900s. And you can see these Acadian farmers there making the kind of classic alterations from saute agriculture. They would build up high levels on the marsh called embankments that would kind of block the tide from getting onto the marsh. And then they'd also dig systematic drainage systems up into the marsh that would kind of allow them to control water flowing both onto the marsh and flowing off of the marsh. The saute was used for livestock, mulch on gardens, thatch roofs, a lot of uses, and it was really a pervasive activity and really valuable for early settlers. And so super pervasive, 95% of marshes have been altered at some point from these types of practices. But I don't personally know any saute farmers. I would love to get a poll from the crowd to see if anyone knows folks, but those activities aren't really common anymore. So all of that infrastructure is just left out on the marsh and is continuing to degrade and impact hydrology over time. And that degradation and that altering of hydrology is causing that marsh subsidence and loss of marsh health. I just wanted to highlight some cool historical images and this sluice gate kind of system where under the embankment there would be this valve that when the tide came up, that valve would shut so the water couldn't go up onto the marsh. But when the tide was low, any marsh fresh water could drain from the system. And here's just some cool images. This is a staddle where they would harvest hay and allow it to dry on site before they took it off site. And you can find signs of agriculture in a lot of places. So this is an old boat wharf where they'd harvest the hay and then take it off site downriver. You can see the impacts from aerial imagery. This is a really extreme example, but you can see all of those kind of straight lines through the marsh, and those are old ditches, either from agriculture and or mosquito ditching. And so you can just kind of put the pieces together that this is a big change in the way the marsh functions. You'll see them on the landscape. This is an old embankment with kind of the borrowed ditch on either side. So they'd dig ditches and use that material to build up the elevation. Here's an embankment going right to left, and the trunk ditch that would have had a sluice valve underneath there. Ditching can have various different kind of looks. You have massive ditches. This is on the Narraguagus River, or you can have these small marginal ditches that are kind of very set on the landscape. And I don't know if folks recognize this view, but this is the Walsh Preserve, owned by FCT and managed. Has a great trail to the marsh, and you can kind of see some old, you really are looking for kind of straight lines, and these are some of the examples of those features out on that marsh. This is Walsh Preserve from an aerial imagery, and through our restoration project, we have all of the agricultural features mapped by the SMART teams. And so this is what they could find out on the site. So all of those straight lines are either embankments or ditching structures based on the different colors. So, whoa, they're everywhere, and they're really changing the hydrology of the marsh. And so I'm going to kind of go through this, and then in the sake of time, I'm going to go through it kind of quickly. But there's kind of two pathways of like, how does those changes degrade the marsh, right? One way is that it's providing too much oxygen, so kind of overly draining the marsh. The other path is that it's causing water to be held on the salt marsh and leading to plant death and that kind of thing. But ultimately, it's all about hydrology, right? So both of those things kind of feed into, we have messed up the hydrology and that needs to be fixed through restoration. So that oxidative subsidence trajectory or too much draining causes this, where the kind of groundwater goes to the bottom of the ditch, and now you have all of these thick layers of peat exposed to air, and microbes can start to consume that carbon and that rich carbon that I talked about before, and that causes the marsh to kind of deflate, basically. All of that organic carbon goes away. So that's kind of the oxidative. For the waterlogged, basically those embankments have trapped water on the marsh. And if you remember, like the key processes, those plants that are adapted to living on a salt marsh need to have that flood tide go away. And so if they're totally saturated, if their feet are wet over and over and over again, they just start to die. And when that happens, you get features like this, which we call megapools. So there's no living plants in those areas, just standing waters. It changes the chemistry. They start to expand really rapidly. And so I'm going to show you a series of those expanding megapools here at the Walsh Preserve. So this is 2006. You can see, especially like right there, right there, if you focus there, you can see all of the kind of remnant vegetation that does exist will start to kind of get eaten away by the expanding. It gets more and more waterlogged through time. So this is 2013. And then by the end, 2025, this is the most recent aerial. You can see that the megapool is just expanding and more plants die. And when there aren't plants, the marsh can't do those key processes of provide habitat, of store carbon, of respond to sea level rise. And so you have this is a very overly simplified diagram, but you have in this kind of lighter green going down, you have marshes that are actively subsiding. Then you have other marshes that maybe aren't subsiding, but they're not getting enough sediment, so they're not accreting fast enough. And then you have sea level rise. And regardless of what kind of marsh you're looking at, eventually those lines kind of intersect. And so the salt marsh is no longer in that proper position relative to sea level. And so it will convert away from salt marshes into kind of like a mudflat type system. And we don't want that. We want to keep those benefits of salt marshes through sea level rise. And so what restoration is trying to do is to revise that trajectory from subsiding through oxidation and through waterlogging into an accreting kind of trajectory. And so to do that, and I'm going to try to go fast so we can have time for questions, is to really establish kind of single channel hydrology is what it's called. The agriculture created all those straight lines and parallel hydrology. We wanted to kind of return to a more natural system like this, where it's almost a dendritic pattern or like a tributary style hydrology, where there are channels that come in and then branch. And so there's two kind of things that we need to do. We need to remediate the ditches that are causing too much oxidation, and we do that by securing salte at the bottom of the ditch, which acts as a substrate that captures sediment and starts to mimic the peat on either side. And you kind of build that and layer it over the course of 3 to 5 years, and that brings up that groundwater. It makes it so oxidation isn't happening. And we kind of heal that scar on the landscape. And here's just an example from a study from 2009 that did this. So you can kind of see an untreated ditch on the right versus the treated ditch, which starts to just have vegetation and you wouldn't even know it was there. So these are some kind of action shots of a gentleman out with a little mower, and then they mow the grass. They kind of use this hay rake to roll it into a bundle. Then it's secured at the bottom of the ditch, and it's just secured, and you do that over time. And then the flip side, right, the other part of these projects is to deal with those areas that are too waterlogged. And to deal with those, we do what's called channel remediation, or if you hear Carrie talk about runnels, this is what we're talking about. So runnels are basically intentional small pathways, flow paths that are 2 feet wide, 10 inches deep, that are just reconnecting those isolated areas of the marsh that are holding water, and we're connecting them to tidal exchange. And so that's really a core part of that single channel hydrology. And so we do that with equipment sometimes. And so this is a little excavator. There's a specially made bucket to get that shape that was in the last slide. And the operator will use these weight dispersal mats and kind of leapfrog those across the marsh to make these really uniform runnels and to not impact the surface. And so actually the pounds per square inch of that equipment is less than I would be out on the marsh. And so that's a really core tenet of this type of work. I know it's really intimidating to see an excavator out there. We'll also dig it by hand sometimes if access or if it's too waterlogged, does the equipment get out there? So that's a possibility. It's pretty fun if you can make it happen. It's also very hard work. I don't know how the farmers did it. And this is what it kind of looks like through the life of a project. So we dig this runnel. I didn't mention this before, but you have all this peat from that process, and we build microtopography on the salt marsh. So we shape these low 8-inch mounds with that peat and kind of secure it, and that can form these high elevation refugia where different plants grow, potentially salt marsh sparrows could nest if they are drawn to it. It just kind of creates more heterogeneity on the landscape. And this is one of those mounds after the first year. So they really quickly revegetate and are just kind of very subtle on the landscape. And so now I'm going to run through a couple project photos. This is a project in Hancock, Maine that was MCHG's first project, but you can see kind of classic megapool, nothing's growing there, not resilient at all. And after the project, you can see that water is successfully getting off the marsh at low tide. That's the goal. And that's not to say that this never has water in it, right? At high tides that get up onto the marsh, that will be full of water. It just has that ability to also leave the system. And so now just some monitoring photos. It can be very subtle. The idea, once you kind of restore these pools, the vegetation really just grows in from the edges. Those plants just find conditions that they can grow in now and kind of start to really shrink those pools. So this is year one. It's mostly that lower right-hand corner that you'll notice the change, but that starts to fill in. And it's really as simple as this. You can see this marching line of Spartina alterniflora just going into the pool once we've restored. So that's the goal. Just some more images. You can see this picture was in year one, and this is year two. The plants get more dense, they're growing farther, that's the goal. And this is my favorite series. A very small pool that is actually a runnel goes all the way through it. And then Salicornia or pickleweed comes in really, really hard and is totally revegetating, and that's just over the course of 1 year. So change can happen really quickly, and that's what we want to see. We want these areas revegetated so that soil is stabilized, we can store carbon, and it's more resilient. And then that's that same site just from an aerial view where the left hand has been restored, and so you can see areas where, again, it's not all standing water will be gone, but it's not holding it as hard as that eastern portion that was not restored. And then I'm just gonna have a couple more slides, talk about wildlife considerations. So, like Matt mentioned, we're really restoring the processes, those key processes of the system that support all the other layers in the ecosystem. But we wanna make sure that we're also keeping wildlife in mind. So all this work basically happens outside of those key life cycles, typically over the winter, into late fall, and then before summer really starts. Salt marsh sparrow is a particular concern. They nest directly on the marsh platform. They weave these really delicate nests, and so they're very sensitive to subtle changes in sea level rise, and they've seen an 87% decline in their populations over the last 50 years. And so we want to make sure that we are not letting marshes continue to subside, that they're growing, that they can accrete and keep up with sea level. And that's really our goal. And then shorebirds are also, if you go to Walsh Preserve, you'll see shorebirds. They roost and forage in salt marshes during high tide, and they can be seen in pools. And like I said, our techniques will not eliminate all the standing water on the marsh. And then we're also doing some really exciting monitoring at Cousins River, where we've deployed some audio recording units or ARUs at the marsh to track the changes in shorebirds and also summer resident species throughout the life of the project. So that's a really exciting part of this project that, again, leans on that dense partnership that we have. We have so many partners who are invested, and so that means that we have capacity to do additional monitoring, which is really exciting. So, Cousins River Marsh. This is the kind of timeline of how we've gotten to where we are thus far. The Cousins River Collaborative formed in 2023. In 2024, we hired Jeff Wilson and the SMART teams to develop those restoration design plans. In 2025, we got funding from the EPA to do the implementation of the project. And then once we got funding for that, we started our permitting. We're doing the first phase of implementation just right about this week, literally, at Walsh Preserve in particular, to kind of do initial hand-dug runnels to release some of the waterlogging that's really, really prevalent at that area. Excuse me. And then this fall and into next winter, spring is when things will really be active. That's when we're going to have that equipment out there and start to dig more runnels. And then that ditch remediation treatment is very repetitive, and so we'll do that iteratively over the next 3 to 5 years, and then monitoring for the next 10 plus years. We're never going to really leave the site or leave the project. It's a continual relationship, making sure things are responding the way we want them to. So I'm just going to end it here of just this brief run through of the kind of designs for Walsh in particular. So you already saw this. This is all the mapped agricultural features. This is the kind of proposed single channel hydrology. You can see various entry points onto the marsh surface that will kind of feed areas with sediment, but also let it drain properly. And what that translates into are these activities. So the purple and the light blue are runnels, and then the pink fuchsia up at the top is the ditch remediation. And so those are the kind of activities that you'll see in the changes that will be happening. And I think I'll end there. I'm not sure what time we have, if we have time for questions, but if you want to dive into this deeper, Matt and I and Julia are always available to talk. So thank you.